We'll begin this week by looking at some basic statistic functions that Matlab has built into it. Now, this is not a statistics class, but I do want to go over some of the basic functions. We're not going to go too deep into anything, but I will give an overview of the different type of statistical analyses that we're going to be doing in this class. So oftentimes we have some collected data, some measurements of something that we want to run these tests on. So to go through some of these functions here, I'm going to load into my workspace something called L05 sample, and this is a mat file. Alright, so I load that into my workspace. I have this vector A, and it just has a bunch of different numbers here, and this is going to serve as our test data for these examples. So I have 100 different data points that I want to run these different statistical analyses on. So the first thing, the most common, is finding the mean or the arithmetic average of our data. So remember, the mean or the arithmetic average is if we sum all of our data and we divide it by the number of data points we have, gives us the arithmetic average. So if I type in here mean of A, and I run that, I get negative 0.1108. And we see that there's another way we can do this. If we take the sum of all the values in A and then divide it by how many elements are in A, we should get the same value, and we see that we do. Just much more convenient if we want the average or the mean to use the mean command. Along with the mean, we're often interested in the median or the middle number of our data set. Now here we have an even number, so it's really going to be the average of the two middle numbers is what the median is going to give us. We see that the median and the mean are not equal. They are different numbers here. For the median, negative 0.0299 is the middle value of our set of data. Now if we look just as a test as smaller data set to see how this is working. Alright, so let's make B the smaller data set here. So it only consists of 5, and I've entered them already sorted. So if I take the median of B, if I want the median, it's the middle number. I have an odd number here, so I should get 5 as my answer for the median, and I do. However, if I take the mean, it's going to be the sum of all the numbers divided by 5. I get that the mean of my set B 5.6. Now we can also find the mode. Now the mode is not going to be very interesting of A, because A is just a continuous set of numbers. It's not discrete data points or discrete numbers like we can see in B. So if I take the mode of A, I don't really get anything useful out of it. It just gives me really the smallest number there, because they're all the mode. They all appear one time. But if I look at a set B, say I make B 1, 3, 5, 9, 9, 10, obviously I can see what the mode is here. Is going to be 9. It appears the most times. It appears twice. All the others appear only once. And if I edit the set, if I put 3 instances of 10 and run that, now 10 is the mode. It appears 3 times, 9 appears twice, and the other numbers appear only once. I can have Matlab find different percentiles or different quantiles. So this would be if I wanted to find like the 25th percentile, the 90th percentile. Basically what it does is if I sorted all my numbers, I found what number is higher than 90% of them. That is going to be my 90th percentile. Or same for the 25th percentile. If I put all the numbers in order, what number is higher than 25% of all the numbers? So to use that, I can use the quantile function. And I'm going to give it the vector I want to find the quantile of, and I tell it which quantile or quantiles or percentiles I want. So for example, if I want the 25th percentile, I'm going to put 0.25 here. Get rid of this. So the 25th percentile of this data set, I get 0.7012, negative 0.7012, so 25% of the data is less than that number. If I want the 90th percentile, I should expect it to be a more positive number. It is 1.1374, so 90% of the data in A is less than or more negative than that number. And if I find the 50th percentile, that's actually exactly the same thing as the median. Just to double check that, I get the same answer. The 50th percentile is the same as the median. What I can also do is not only put a single value in here, but I can put a range of values. So let's say I wanted the 10th through the 90th percentile. So I can put a vector in here. This is going to be 0.1, 0.2, or 10%, 20%, etc. until 90%. And if I run this, that gives me in that same order the 10th percentile, 20th, 30th, 40th, all the way up to what the 90th percentile is of this data set. Let me remove that. We also are going to be interested in the standard deviation of our data. That's going to be STD. And if we run that, we find that the standard deviation of that data set is 1.0163. And what the standard deviation tells us is how much does the data spread from the mean. So how far apart is it, how far away is it on average from the mean value. The larger the standard deviation is, the further away it is. And we'll see graphically what this is going to translate to in a little bit. And the last function I'm going to look at is the sort function. Now if I just do sort on A, let me just refresh what A looked like. A had all these numbers in a seemingly random order here. We have negatives, we have positives, some of them are bigger than others. When I use the sort command, it by default is going to put all the elements in A in ascending order. So if I run this and print it, so we see all those same elements, but now it goes from the smallest number all the way up to the largest number in that order. Now by default, sort is going to put it in ascending order. If I want it in descending order, I'll explain why there's a 1 here in a second, but I have to specifically tell it in the third command to put it in descending order. And in this case, now the first number is the biggest and the last number is the smallest. And if I say ascend, well, that's just like the default. It puts it from the smallest number to the largest number here. Now so far I've only used these functions, these statistical functions, on vectors, but they also work on matrices, but it's just a little bit more complicated to use them. So let me expand B out here so we can see how it's working. I want the same number of elements. So B has 1, 2, 3, 4, 5, 6, 7, 8 elements on top. So just choosing them randomly here, I'm going to put 8 on the bottom as well. Okay, so I have B is now this 2-row by 8-column matrix. Let's see what happens if I try to take the mean of B. Right, so what we see here, if I say mean of B, I get 8 values here. So by default, if I have a matrix, it's going to find the mean down columns of data. So we see here the average, the mean of 1 and 5 is 3, 3 and 6 is 4.5, 5 and 8 is 6.5, etc. till I get to 9 and 10 is 9.5. So this, by default, takes the mean down the column. And that's what the second optional argument means, is the dimension of which to carry out this function. If I put a 1, that means carry out my function down columns. And that's also what the default is. But my other option is, at least for a 2D matrix like I have here, if I put 2 in for the dimension, now it's going to take the mean across a row. So we see here I only get 2 answers because it's taking the mean of 1, 3, 5, 9, 9, 10, 10, 10, and that's 7.125. And then the second value is the mean of 5, 6, 8, 4, 2, 1, 0, 9, 4.375. I can do that similarly if I take the median of B. Again, it does it down the columns by default, and the same if I put a 1 in there, or if I want to take the median across the row, it picks out the middle number in the top row and the middle number in the second row. And this can work on other types of matrices also. So in this case, I have a 2-dimensional matrix. If I were to have a 3-dimensional, 4-dimensional matrix, I can take the means across rows, down columns, across ranks, and so on in these higher dimensional ones. We're really going to stick to 2-dimensional matrices at most in this course though.